Yeah, so I thought it would be fun to stream for a little bit today to um, talk about re-implementing the entity manager a little bit in cluster because I'm not really happy with the current state of the entity manager that we kind of have right now. And I thought since we're in the phase of rapid development, this would be a good time to think about re-implementing it. Um, some of the things that I thought would be good to consider would be to use a scope to control the entity and the entity manager's lifecycle. So the idea being that the entity manager itself has a scope that controls um, the lifecycle of the entity manager. So when that scope is closed, for example, all the entities managed by that entity manager would be terminated. And then similarly, the actual entities managed by that entity manager could have a child scope forked off of the manager's scope that would allow us to attach resources. Because at the moment, we're currently doing a lot of manual bookkeeping. And yesterday, Tim and I started playing with using a scope to do some of this stuff, and it seemed like it might be a little bit cleaner. Um, and the other thing I want to do for the moment, Shardcake has this concept of termination messages. Um, but I think we can ignore termination messages for the moment. Um, Basically, they're like messages that get that allow you. It's a way to fire off a message to the entity when the manager signals that the entity is terminating. Um, it might be useful in the future, but to simplify things and allow us to implement this the way that I think is more I don't know, correct. We're going to ignore termination messages for the moment. Yeah, so let's maybe get started. Um, so I think we'll model the manager the way they currently manage or model the entity manager um, is with a couple of methods on an object. Again, I want to kind of trim this down. I think probably the only thing that we need is to be able to send to the entity manager, because all of the termination related stuff could be scope related. I mean, maybe we want to have the ability to terminate entities on specific shards, but for now, not gonna. I think I'm gonna focus on send. Termination can come later. So make still needs to accept some arguments. We need the entity that's going to be acknowledged, and we still need the message type. Message. Oops. Wonder if we can just do. We still need the behavior of the entity. And this is going to be so I was talking with Tim yesterday about this. We could model the behavior as an effect of void, but I think we'll keep it at the moment as an effect, like a never ending effect. Um, I think this still makes sense for the moment. The behavior is going to get a few things. The first argument is going to be the mailbox. And we could use effects new mailbox module for this, but I am not. Why don't we actually do that? Let's use the new mailbox. for this, and then we can always revert back to a queue if we need to if we want to for some reason. But mailbox is pretty flexible. And the behavior is only going to get the read-only side of the mailbox. And we'll ignore the registration options for the moment. So I still think managing all the entities as with a synchronized ref is a good idea, because there are certain cases in here where we're doing asynchronous work and we want to be able to lock the entities for writing while we do that. For example, when we get or create the entity state, we modify this map effectively. So I think we still want a synchronized ref here, so that when we're doing that asynchronous work, we can make sure we're locking this for writing. Because inside, for those of you who don't know, effect has a normal ref, which models a mutable reference to an immutable value. But we also have synchronized ref. Synchronized. If I could spell synchronized. And synchronized ref is basically a ref that also includes a semaphore with a single permit, so that you can lock the ref for modification while you're doing asynchronous work. So while a ref only exposes kind of like an atomic API, synchronized ref also allows you to do effectful stuff to modify the ref. But synchronized ref is not really that useful if you're only doing if you're only doing synchronous operations on the reference. But since we're not, we can use this and make the synchronized ref, and we still need a hash map. And this is going to be a hash map of entity addresses to some entity state that we have yet to define. Where did my hash map go? Oh. Maybe we can do this now. Interface entity state message extends. So before we were modeling entity state as a discriminated union, a tagged union of an entity being active and an entity being terminating in a terminating state. But I want to try doing this where we just have the entity is either alive or it's not. We'll see how it goes. The entity state is going to need the mailbox, and in this case, we want the read-write interface for mailbox, and it's going to be a mailbox of messages. Again, we could use Q for this, but I want to try out mailbox just to see if it's useful for this use case. And then the state of an entity is also going to have a scope, which we can use to attach resources and then clean them up later. And it's going to be a closable scope, because we want the ability to manually close an entity's scope. So yeah, I think this makes sense. So the manager is also we're going to grab the scope from the manager. All right, scope. So creating an entity manager is a scoped operation. So this allows us to grab the scope that will be eventually provided to the entity manager. And then I want to look at recreating this get or create state for an entity, um, because yeah, I think this is like where kind of some of the interesting stuff happens. So, and this is what's used to forward messages to an entity. So, to kind of like recap, like what an entity manager is, I probably should have done that at the beginning. The entity manager is essentially what it sounds like. It manages entities, but are on a given pod in the cluster. You have a sharding instance per pod. So there's a sharding service on that pod, and that sharding service has n entity managers, which correspond one to one to the number of entity types on that particular pod. So what I mean by that, let's say like you have, I don't know, like user entities and to do entities and I don't know, some other type of entity. Um, These are entity types, but you could have multiple user entities registered to a given pod, right? You could have user one, user two, all the way out to user n. Similarly, you could have, to do one, to do two, and to do n, all on a given pod. And these could be in like separate shards on the pod, right? That's not really the what's important here. The point is that on a pod you could have different entity types, and you could have multiple entities of the same type on a pod. The entity manager corresponds one to one to entity types. So we could have an entity manager that's managing the users. We could have an entity manager that's managing the to-do entities. So for all of these user entities, we'd have one entity manager that's managing them. Similarly for the to-dos, etc. So the idea is on a pod, you have many shards. Entities are registered inside the shards. And that's again like an addressing optimization. But the sharding service that's on the pod is managing or has a bunch of entity managers that are used to kind of manage the life cycle of the entities within each shard. So again, could probably even make this more uh, s- a little more clear. Sharding, which is on the pod level, may have. Hopefully, this makes sense. The sharding service has many entity managers, one per entity type, and the entity manager manages all the entities on that pod um, for a particular entity type. So, um, and that makes sense because, when you register a behavior for an entity, um, that behavior can only handle messages for that particular entity. So yeah. Um, let's keep going. So when we call getter create state, um, it's really only called by this send method. So send is what's used to take the envelope, which is basically like the encoded object that has the entity address information, as well as the message that needs to be sent to an entity in it. And when we call send, we decode the envelope using the schema of the entity. Um, and then we attempt to persist that message to cluster storage, and then we send that message to the entity itself. And this send message to entity method calls getter create state to basically, if that entity hasn't been provisioned yet by the entity manager, it will provision that entity and then create the state for that entity. Otherwise, it just returns the state directly. So I want to focus on getter create state for a moment. Get or create state, and we're going to take in an address, which is used to grab the entity out of the map if it exists. We'll do that. So synchronize draft.modify effect entities. have our of entities here. We can do an auction.match. We need to import auction. So a lot of this is the same at the moment, but trust. So if we don't find the entity, if we don't find an already registered entity in the map, then we need to do all the logic to set up the behavior for that entity and basically provision the entity state. But if we do find the states, maybe we can do that case first. That's easy. On some state. So modify all of the ref modification APIs return a tuple where the and where we're going to proceed where the first element of the tuple is the thing you actually want to return. So if you like, in this case, we want to return the entity state. And then the second element of the tuple is the value to put back into the ref. So in this case, we're just going to put the map back because we don't need to modify it. In this case, the state was already there. So we return the state directly and we return the map unchained, or put the map back into the ref unchanged. But in the case that we don't find the state for a given entity, we need to provision everything related to that entity. So we can probably copy some of the logic we already have. Entity not managed by this pod. Yes. Like, so when effect, if the sharding service is shutting down, is shut down. We need to grab sharding from the environment. I think I have to import it. So if the sharding service is shutting down, then we basically return an entity not managed by this pod exception, because if sharding is shutting down, then there are no entities managed by the that pod. So we need to indicate to the cluster to essentially retry that message, or the client, I guess. Where is it? Here we go. So some of this logic again we can reuse. So but if the sharding service is not shutting down, then we can start to provision everything we need for the entity. So let's rename this to manager scope, like we did on the right. Right. So I don't know. I'll point out some like weird, maybe stuff that newer folks to Effect might not be familiar with, if I can remember to do that. Otherwise, if there are questions, just ping me in the chat. but zip right is like essentially doing a flat map, and ignoring. It's essentially like a flat map, and then you just ignore the argument that comes in here and return whatever effect you want. So it's just kind of like a terser. You could also do end then, and the effect that goes in there, but I like to use zip right. And we want to now, so we want to create the scope that's going to be used by the entity to attach like its resources that we can then close later. So in order to create a closable scope in effect, we can fork a new scope off of the manager scope. And this also has the benefit that if the manager is shut down, so if the scope of the manager is closed, all of the entities will also be will also have their scope shut down, which means that like um all of the stuff associated with the entities that we need to manage the lifecycle of kind of gets managed automatically. And we need to give it an execution strategy. We want the finalizer, we want it to be sequential, I believe. So we'll just leave it as sequential. Execution strategy. Execution strategy. Sorry. Yes. So we can use effects like bind APIs to help us here. So we can bind this scope to a variable named scope. This just creates like an object inside our little pipeline here with like scope bound to scope.closable scope. And see what I mean when we actually use it. Um, and we can probably follow a lot of the logic that I had here from yesterday. The mailbox to tap. Um, and this mailbox is going to take messages. Um, and I'm using like the add finalizer stuff here. Basically just to manually attach finalizers to this scope. It's like one way that you can manually attach finalizers. And so essentially, again, every resource that we want to attach to the entity scope, so this scope that we're forking off the manager scope here, this scope we're calling like the entity scope, all the resources that need to be shut down when the entity is shut down, we can just attach finalizers to this scope. So mailbox.shutdown. And now again, if we close this entity scope here, the mailbox will be shut down. And if we shut down the entity manager, similarly the mailbox will be shut down because um, we're forking the entity scope off of the manager scope. All right, so let's continue. We need to start the behavior. And since we don't need to bind that to a variable, we can just grab the mailbox and the scope. Behavior, mailbox. Just seeing if there's like, if I have to call read only or if it's just an interface. I think it's just an interface. And then there will eventually be a second argument here, which will be, I don't really know what to name it yet. I think something like entity or entity info or something. But that second argument that I want the behavior to get will have methods on it to allow the user, because the user is the one who provides the behavior to the cluster for like an entity. This second argument would be used by the user to do things like acknowledging or marking messages as processed in their behavior. Um, and we can also attach information about the entity to this argument. So things like, I don't know, the address of the entity, the ID of the entity type. Um, so we could attach like various metadata to this. I don't really know what to call it yet though. So we're just gonna leave that as a to do for the moment. Implement um, and then we can use effect.ensuring. Basically, if the behavior exits for some reason, so if the user interrupts the behavior with like an effect.interrupt or whatever, if the behavior exits, we want to close the um, we want to close the scope. And we can just give it exit.void, the value that we're closing it with. And then we can fork this behavior into the scope as well. So we have, again, this is a little bit of scopeception, but the idea here is behavior is a user defined construct, right? So like when you're defining an entity, um, you're going to give that entity some behavior. Uh, so when you do like in pseudocode, we just imitate this for a second. Somewhere in like an effect.gen when you're defining what happens with your cluster, doesn't have to be an effect.gen. I guess it's a little easier to read imperatively. You would do something like sharding.register entity, my cool entity, and then you'd probably provide the behavior here, right? And behavior would just be some function that has the same signature that we've defined up here, where it gets a mailbox and it's also going to get that second parameter. Um, and so you can do things, the behavior has full control over like what happens in here. So you would do like, mailbox dot take dot pipe, you know, uh, back dot flat map message, and then you would do some stuff to like actually process the message, maybe like switching over the message dot tag or something. And then you can, again, you have full control over how fast you pull messages out of the mailbox. So you could do this effect forever. You could do it on a particular schedule, whatever. Um, but you have full control in the behavior of how fast you're pulling messages. And then similarly, the second parameter here, the entity, once you've processed a message, like say we have a message type that's like, um, I don't know, maybe my cool entity is a counter and we have like an increment. We would do something like entity dot um, acknowledge. We could acknowledge messages with this entity dot acknowledge thingy. We could also do entity dot process or mark processed, whatever makes the most sense. And then, um, you know, it. The point being here is like the idea is to give the user as much control as we can inside the behavior. So inside a behavior, you would be again full control over how fast you take messages, and you have the ability to acknowledge and process messages. And eventually, these entity dot acknowledge, entity dot mark process. Hey, Mattia, how's it going? Um, eventually, these like acknowledge and process APIs that the user gets access to in the behaviors would be connected to back to like the client actually calling the cluster with that message, right? So if you imagine that you have a client where somewhere else you're doing like sharding dot messenger, right, to get a messenger, and then you do messenger dot tell some message, right? When you actually tell the cluster a message, you don't need to wait for the cluster to actually process that message or like fully process that message. You only want to know if the cluster is going to acknowledge that message. So when the entity actually if that's the case and the entity like actually acknowledges a message, that would be when the client would actually get the response, "Hey, we received your message." Um, and that would be the like kind of the idea. The other way we could go about doing this is instead of allowing the entity to acknowledge the message, um, and that be the response that the client gets, we could say that as soon as the message is persisted into cluster storage, that's considered having acknowledged that the cluster received the message. That probably makes more sense semantically. So I guess like in this case, the ask API, like when you ask in cluster parlance, that means you actually want to wait. You're asking the cluster uh, for a response to this message. Um, and in that case, when you mark a message as processed with some result, that result is what the client would then back. So a little bit of a long-winded explanation of what's going on here, but that is the idea with the behavior. Is that the behavior gets access to the mailbox, as well as some object that we have yet to name that probably for the moment will just allow acknowledging messages and then maybe provide some entity metadata like the address and whatever. And then we fork that behavior into a fiber that's attached to the entity scope. And then this effect.ensuring basically allows us to close the entity scope if the behavior exits for some reason. So whether the behavior exits with a success or a failure or is interrupted or whatever, we can be sure that the scope is going to be closed um, by having this ensuring block in here. Um, yeah. So cool. Hopefully that makes sense. Why am I getting so many type errors? Oh, it's because I don't. Yeah. Okay. So that handles the behavior. But we still have a few other things that we want to do here eventually. So to dos. Um, one is we want to have the ability for the cluster to provide you with metrics by default. So we can over here you can see I'm actually handling like a gauge that's created to basically increment and decrement. So when the entity is actually provisioned, we increment the gauge to basically like show you how many entities of a particular type are actually registered. And then the finalizer is basically decrementing that gauge. Um, I have to create a PR in effect to add the decrement APIs, but for now we just increment by the negative value. Um, but yeah, so update or add metric bookkeeping bookkeeping here. And we probably want to do it in this order too. So the other thing that we have here is we want to add something that's tracking like the last time an entity received a particular message. So um, sorry, I'm reading something on Matthias sent. How do you plan the behavior to reach for additional data added by the persistence or cluster? Uh, Not sure yet, Mattia. I don't know yet. Probably the mailbox, instead of being a mailbox of messages, will be a mailbox of like some sort of like entry or something like that. You can actually see in my previous implementation of the entity manager, somewhere. I may have removed it. No, here. The old version of Mailbox that I had coded had this concept of like entries where all of like the metadata um that comes back from cluster storage, so like this sequence number of the message and whatever, um are basically added to the mailbox as message entries. So you get the message and then all the metadata as well. But I'm sort of ignoring that for now. Um, so anyways, getting back to the point I was making, the other thing that we want to be able to do here is to track the last time an entity was active. And we've discussed this at length. Shardcake, um, the concept of like active and Shardcake is based on the last time an entity received a message. But I think we decided for our implementation, the last time an entity was active should be based on the last time a message was actually processed, not the last time a message was received. So I'm just going to add this to do in here for myself as well. So we need to update the last active time based on the last message processed, not the last message received. Because in the previous implementation, I was basically doing the same implementation as Shardcake, where the last time, if we receive a message, we update the last active time. Um, but we don't want to do that. So I think probably what'll end up happening here is the management of like this last active time will be done in the method, like the mark processed method of whatever this object is going to eventually be called. It'll make more sense when I actually get to implementing it. Then what was the last thing I did here? Oh yeah, removing from the scope. So because we're running the finalizers of like maybe it's not super clear from the little pipeline that we're setting up here, but the finalizers that we're registering to this scope. So whenever we do like a scope.add finalizer, these finalizers will be run in the reverse order that they were attached. So, or in the order, the last finalizer attached will be the first finalizer run. So, uh, the first like finalizer that we probably want to run um if the entity's scope is closed, the first finalizer that we want to run is probably the one that removes the entity from um the entity map. So we can do that here with back.tap go synchronized ref dot update. Okay. So basically, again, uh, finalizer. Um, if the scope is closed, we need to make sure that this entity is like removed from the entity map. Um, so that like if for some reason we end up in a situation, we shouldn't end up in this situation, but like if we end up in a situation where um the uh we attempt to access that address we like we know that the first thing we've done when we attempt to close when we close that scope is remove it from the map. Um, okay. And then we need to actually return the state that we've built up here. So back map, mailbox, scope. Um, I'm gonna do this, and then eventually, and then might remove the. So I okay. So we can move these to. So again, the final step here is like, since we're at the very beginning, where oh god, hang on. Since at the very beginning here, we're still running this as like a modification of the entities map. The final thing that we need to do is actually return what needs to happen as a part of that modification. So the value that we want to return is the state that we've created, and here the state is just the closable scope and the mailbox. And again, the scope is closable because it was forked off of the entity manager scope. Just accessing a scope, for those who are interested, you get a read-only version of the scope. You can like add final. It's not really read-only. It's not. It's a non-closable scope. You don't have the ability to call scope.close. Um, but if you want to be able to manually close a scope, if you fork a scope, or create one, I think you'll end up with a closable version of the scope. And in this case, since we want to have the scope forked off the manager scope, and we end up with a closable scope anyways, so we're in good shape there. Um, exit is also imported as type. Why? Or it's not imported at all. Great. Cool. So we make sure that the entity gets removed when the scope is closed, and then we return the state, and we also update our hash map to include the mapping of the address that we received to the state. So all of this basically is to be able to give us an entity state that we can then use to communicate with an entity. So if the entity already exists, we return the state right away. Otherwise, we do all the stuff that we need to do to actually provision and manage that entity. Um, cool. So let's now think about send. So we still need to be able to decode an envelope. But you know, and we're gonna use decode unknown because we don't. I mean, we sort of know the shape of what's coming in, but the message that's inside is an unknown. So I'll show you folks the encoded. Actually, I can just do it now. What envelope.encoded looks like. So the encoded envelope basically has the encoded version of the address, which is just the uh, shard ID, the entity type, and the entity ID as their raw values. And then the message is an unknown type in this case when we first get it. Um, and in a previous episode, I think I did this like off stream, so maybe I'll just note this. But in a previous episode, we encoded envelope as a serializable thing. But thinking further about this, like we basically implemented the serializable interface for envelope. But in thinking further about it, envelope's not really serializable because I mean, it is, but once you serialize an envelope, when you transmit it over the wire and it's received by whatever sharding entity manager, whatever, you can't deserialize the envelope with itself because the message is unknown at that point. You can't like reconstruct the schema for that message because the schema is not going over the wire. We need to find the correct entity first and then use the entity's schema to decode that message. So envelope, it didn't really make sense to implement envelope as a serializable thing. Um, so instead, I have basically just added a serialize method here, which just encodes an envelope into its encoded version, creates a little struct internally, and then encodes the envelope. Um, and then to deserialize the envelope, we need to have access to the entity, which we do in the entity manager. So um, entity manager. So here, we can say schema.stripped, basically the inverse of what's happening in the serialize method I showed you folks in the envelope module. But again, because like this has gone over the wire and envelope was fully encoded, I mean, the message was fully encoded, we don't really have the ability to reconstruct the message without knowing the schema of the entity's schema. So, but now since we're in the manager, we can do that. So address, that's the address, and message entity.schema. This entity is the one that the entity manager gets to manage. So entity type being like user to do whatever. They all have their own schema, and then we can use that to decode the envelope, the message of an envelope. So when we actually try to send a envelope.encoded to an entity manager, we can return, the first thing we do is we try to decode the envelope. And we can again use these kind of like bind APIs, which are useful. Envelope, bind, entry. So again, the API of the storage still needs a little bit of refinement, but storage.save message, and we need access to mailbox storage. Storage, internal mailbox storage. And this internal prefix that I use is just, I don't know, a convention that I came up with for knowing when I'm in a module like this, if I'm importing something from one of our internal interfaces, I mean, internal files, or from an external interface, like, or external module, like something that's exposed to the user. Um, storage dot save message, and this gets the envelope dot address and envelope dot message. And this entry is like the old mailbox. So we had a mailbox implemented inside cluster that will be deleted shortly. But first, we need to figure out like what the interface of an entry is going to look like. Probably to start with, an entry coming back from storage. Um, we'll just have like the message and this sequence number. And then we can add additional metadata over time, based on what makes sense. But the entry probably for now will just be like like I said, the message sequence number and the message itself, after it's saved to storage. Envelope. No. Send message entity. We'll basically do the same thing we did over here, where envelope dot address entry. Catch tags. We want to remap some errors to our cluster domain. Um, we want a no such element exception, which happens, I think, from saving a message. Yeah, if we can't, if the I think if I forget exactly what causes this no such element exception. I can take a look in a second, but um, it's when I think we get this when an entity is already or a message has already been saved. I think that's what causes this because we don't get anything back. So if save message returns a no such element exception, that means that it's already that message has already been persisted. And then a parse error. Right. I'm not getting IntelliSense because we haven't function. In this case, we have this malformed message type in our sharding exception. Just give it the cause for now. And I think we still need. Oh yeah, we have to provide the context from the entity manager because that is how we propagate context for a message. So let's actually do that. Let's put the return type on this thing, or at least the beginnings of it. So entity manager, we can read only, send. Just something. Just do this for now. Entity manager, never, and then this is going to need a scope. Going to need the serializable.context. So I'm doing this basically to make sure that we propagate the context for a message into into the entity manager. It's essentially a way to make sure that we provide the context where we need it. Storage. Forget what else we need. Sharding. Okay. We'll flesh out this interface shortly. So what we need context equals. You just copy that, paste that here. We may need serializable with result context, but I don't know if it makes. No, we don't. We need the context to serialize and deserialize a message. We do not need the context to create the result for a message. That context, if it makes sense even to have that context anywhere, it would be on the behavior, not on the entity manager. But the entity manager it needs the so because schemas can have an environment, we need to provide that environment somehow. And at this point, this decode envelope requires the context for deserializing our envelope. So in this way, we can propagate it to the point at which we create the entity manager. Provide context. And it probably makes more sense instead of doing this let's do that instead. It probably makes more sense to extract a runtime, because then um we'll get all of the runtime flags and fiber refs properly set. Let's do that instead. Const runtime equals serializable. That's serializable dot context message. Let's get rid of that. Or with how do I do this? I mean, we could do, the runtime dot. We don't want to run this. We want to set this as the runtime. I just can't remember how to do it. So give me a second. See, even I have to look up the effect API docs. Provide. I forget that provide also takes a runtime. All right, why is this upset with me? Cause has any type. Well, that's because there's no type for send message to entity, I think. Let's implement send message to entity. So this is where things will probably deviate slightly because we don't need some of this stuff. So we can return get or create state for this address. Flat map. Uh, the only thing we're going to have to think about here is what the consequences of like removing this terminating state are. Not entirely sure. I think what's going to end up happening with get or create state. So, the state is always going to be active because the second we close the scope for an entity, it's going to remove that entity from it's going to remove that entity from the active entity map. So I think we can just presume the happy path for a moment, and then when we get to the point of writing tests, we're going to need to test sending a message to an entity that we've terminated. But let's presume the happy path for the moment. So we don't need to do this because, again, for us, the concept of last active is going to be based on acknowledgement of a message, not receipt of a message. So in this case, I think we can just literally forward state.mailbox.offer the entry. This is going to be a type error at the moment, or not going to be a type error, but we need to add a to do to fix this because entry is typed as any right now. Implement entry type. And then we probably still want to do an affect that. Send message to entity. So if it fails, then we just repeat it after a delay. Address and affect that. 100 millis. Cool. And we can probably just move this up here. So now we actually have the type for this. Mm-hmm. Now we can add send envelope.encoded. Whoops. Yeah, right. Void no or not managed by pod or a malformed message error. Yeah, I think this makes sense. So yeah, I think the next thing we can do is implement some of these stub types that we've left, like the entry type, which we probably should put into like the mailbox storage, and delete the mailbox module since we don't need it anymore. Um, and then also maybe the behavior should get like 3 arguments. Maybe it should be like mailbox, like message handlers, like so, and handlers can basically have the same interface that we had for our okay, same interface that we had for our mailbox originally, which um allowed for like uh, both acknowledging a message and then it had some helper methods for like completing or acknowledging messages. Um, we can think about this a little more, but the idea here was like uh, to have a similar interface as like the request type in effect, where there's just some helper methods that allow you to complete a request, either with like an exit or with an effect or with the failure directly or with a success value directly. So maybe this like handlers thing would be that an object with those methods on it. And then we can have like a meta argument, which maybe would have information about like the entity or info, right? Which would be like entity information. Um, but again, we can think about that a little more. For now, I'd like to go to mailbox storage and so um, let's go take a look at the mailbox entry type I had implemented previously. So the mailbox entry had a shard ID, an entity ID, the entity type, the message, and the sequence number, all of which come back from the mailbox storage. I think this makes sense. It's nice to have all this information coming back so that when you pull, like when a behavior pulls a message out of mailbox storage, you get access to all of this information. Then we actually don't need that whole like meta argument thing I was talking about or that info argument I was talking about. You already have it on each entry that you pull out of the mailbox. Kind of nice. So yeah, I think this is good for now. Um, can probably improve naming and stuff later. Let's fix the internal mailbox storage entry. Types are incompatible. So save message is still a problem. Oh, is that it? Hmm. Oh, the context. Serializable. Uh, I don't think we need the with result context, or do we? Save message. No, no, we do not. Because we're serializing the message, deserializing the message. Yeah, we need to revisit the mailbox storage at some point, but I'm pretty sure this can just be serializable context. Cool. Ooh, I know what this is. We need to decide what to do in this case. The other thing is I need to go through mailbox storage and figure out if we are properly mapping errors to like malformed or persistence errors in the correct places. But I haven't really spent a ton more time on mailbox storage. So right now we're focusing on the entity manager. So, okay. So mailbox storage dot entry message, and then the mailbox. And maybe actually we can just make this a little bit easier for ourselves and do this and this. Where is my and obviously like behavior also needs its types fixed. Because technically this is where we would need the serializable with result dot context for the message. um but I'm not entirely sure if never is correct here either. So we'll see. Um for now, let's go back to just ignoring the context. Okay. So at least we've now got mailbox storage entries coming into our behaviors. Um, the next thing that might make sense for us to do is implement these like handler things that we were talking about, these message handlers. Um, but I'm not entirely sure what that will look like, and probably just going to be like a object of methods that the user can call, similar to what I showed before, to either like process a message either directly with a value or with an error or yeah. And we also need to look into this last active times thing, but can't really do this last active time thing until we implement this because the bookkeeping of last active time has to happen inside this like object. So maybe we can do like message create. Hmm. Let's define what message handlers is going to look like first. We'll do it here, but we need to move it to the we're going to need to move this to the external interface at some point. Let's go back to and actually we can look at the internal implementation because there's probably more stuff there. Yeah. So this is like where we would take mailbox storage, update the message, like do all of that stuff. All of the bookkeeping inside storage and with last active time. And the reason why, by the way, we need this like last concept of last active time is because the final piece of the puzzle related to entity termination is um, that we're eventually going to um, have a fiber that we spin up that tracks whether or not the entity should be terminated based on its like time to live. So when you actually create an entity, you can say how long it should be idle for before it terminates itself. So like you can say, okay, if this entity is idle for 10 minutes, doesn't process any message in 10 minutes, go ahead and terminate it. And that happens when you actually register an entity. So you do like sharding that register entity, you do the entity, the behavior, and then there's options. And in those options, you have the ability to define the idle time to live, which is just a duration. And so inside the entity manager, we need to spin up a fiber for every entity that tracks on a particular like schedule, how like when the last time the entity was active and whether or not the entity should be terminated. So so for now, why don't we just have a valid method. Hmm, this. It would essentially implement the same thing that complete is doing here, where we create a processed message state and then update storage with it. We also need to update we need to create a map of last active times and update that as well. Um, mm, I think I had actually defined somewhere what needed to happen. Yeah, here we go. Update the database. This is also a place where we could communicate the result back to the client, and then also mark the last message processed time. I think I need to think more about this before working on it, and I also need to grab lunch. So anyways, I hope you guys enjoyed the stream today. I'm gonna try to stream on a more regular schedule. If I can do twice a week, maybe like Tuesdays and Thursdays at around this time. But once I can establish a schedule, I'll definitely like update my Twitch with it. But anyways, I hope you guys enjoyed the stream today. Yeah, if you have any suggestions for future streams or things that we can do to improve, let us know. And otherwise, until next time, cheers, guys.